All right, this is page 2, and I'm going to try to do page 2 and 3 together. So this page I'm basically reading to you and explaining. So I'm going to go kind of fast, but it's all written down there, okay? So this is page 2 of section 3 when we're talking about positions. And we talked about percentages. Now we want to talk about quartiles. Quartiles divide or order your data or sort your data into 4 equal parts when they're in order. Okay, we're going to have quartiles, so 4 sections, 4 quarters. The first quarter is 25% of the data. Second quarter is the next 25%. Here, let's look at this data right here. See how this is all lined up in order. These are ages of 18 students. So we have a sample size of 18. We line them all up and we find the median. We already found out how to do this. This is an even number. Therefore, our Q2 is between these two numbers here. It's definitely the median. We're now also, if we're talking quartile verbiage, we want to call it the median is the Q2, okay? So when people are looking for Q1, Q2, Q3, the Q2 is the median, all right? So we divided this in half, the data. 18 means there's 9 data points below the mean and 9 above. So that means there is, to find the middle of the lower half, there's going to be 1 data point. So here's 4, here's 4. So this is the middle of the lower half. We're going to call that Q1. Okay, it's the median of the lower half. The upper half is 4 and 4. We have an odd number of 9 altogether. So this is the Q3 number, or the median of the upper half of the data. Okay, so our Q1 is 18, our Q2 is 20.5, our Q3 is 25. Okay, not too bad. So if each of these sections are 25% of the data, 25% of the data, 25% of the data, 25% of the data, first quartile, second quartile, third quartile, fourth quartile, okay? Then we're talking the IQR is the interquartile range of the center 50%. From here to here is your IQR, okay? And how we get that is whatever this number is, 25, minus this number for your, so this is the formula. So 25 minus 18 is 7. So that is the interquartile range. Okay. The entire range is the max minus the min is 26 years. The center data, where is most of your students, 50% of your students going to lie in the center, 50% is a 7-year range. Okay. And then here is the formulas for actual outliers. So mathematically speaking, are any of these numbers really high or really low? Well, we need to do the math for that. So if your data is arranged in order, you find out your Q1 and your Q3. For an extremely low value, it's Q1 minus your IRQ times that. Make sure you're doing this first and then subtracting it from the Q1. And then the extreme upper value, you're taking your Q3 and adding it to your IQR 0.5. So in this data set here, the lower Q1 is 18 minus your interquartile range times this. Subtracted from it, you get 7.5. For the extreme lower value limit, it would be 25 plus 7 times 1.4, 1.5, that gives you 35. So 7 is way down here. You're not going to get a 7-year-old in your class. But up here, 35.5 is in here. So anything more would be an extreme high value or an outlier on the upper side. So 42 is an extreme value in this data set. Okay. So what do we do with our quartiles? Well, mostly we do box and whisker plots with them. If you're doing a project for me, you will be doing this on your project. You need a 5-number summary of your data set on a properly scaled number line. There are 2 parts to a box and whisker plot. The number line, so you can get the scale going in the right direction. And then that helps your boxes and your whiskers be proportional to your data. So this one looks very even, but in real life, this whisker may be way out here, this one shorter, or you might have huge whiskers and little tiny boxes. It shows you visually how much or how little the numbers are clumped around certain areas or certain values. Okay. So the 3 quartiles and 2 whiskers, 3 quartiles and 2 whiskers, 4 quartiles and 2 whiskers. I don't know why. Order data instead of 4. That makes 5. That should be 4. This should be 4 quartiles, including 2 whiskers. Divide order data into 4. So 25%, 25%, 25%, 25%. The whole box, the middle center, the IQR box is the center 50%. Your 5-number summary, minimum, Q1, Q2, Q3, maximum. There's your 5-number summary. Okay. Extra long whiskers may imply outliers. We have the formula to figure out if they're actually outliers or not. We have the vertical boxes. Technically, you sometimes don't see this line in the center of the boxes, just where the whiskers are, but interquartile range. Okay, remember, this is the median, not the center of the box. There is a center of the box. If you do a mid-quartile, center of the box would be Q1, Q3 added together divided by 2, and that would find the center of the box that might be in a different spot. Okay, that's the mid-quartile. Okay. Let's see. The other data is the piece fall at or below, at or above. Basically, I would think about it as above and below. I don't think it's at or above. All right, so let's do an example of this. We are going to draw a box and whisker plot or a box plot. Here's my order. I need to find my 5-number summary if it's not given. So in the homework, they may just give you a bunch of data. You have to put them in order, find your medians, find your Qs, and get your 5-number summary. In this example, here's the 5-number summary just handed to you. Okay. Construct a horizontal or number line, a scale or a number line with the range of the data. So what I want to emphasize is my minimum and my maximum. So I need a scale that's going to cover these values. So I'm going to start down here. And if I make that a 40, that's certainly encompassing that. And then kind of space up 40, 50, 60. Try to be a little even if you're doing this by hand. And then you want to go all the way up to make sure you have that 96. So I'm going to go to 100 and then kind of move that over a little bit. Okay, there is my scale. So I want to put that 96 in while I'm up here. Let's see, let's put the 5s in approximately. So 6 would, I don't know, be about there. I label it just to make sure it's close enough. 83 is my Q3. My Q2 is 78, which is pretty close. And my Q1 is a 69, which is also kind of close. 69. All right, so this is my box and 1 whisker. And then my minimum is 45, which is there. And that is my other whisker. Okay, so there's my box plot of this data. Kind of gives you an idea. We got a little longer whisker here, a little shorter box here. So let's ask some questions about this. What was the average test score in the class? Well, what's the 50 percentile? Is the 50th percentile is the median, which is 78. That's the test score. That's an X value. Okay. A data point. Scores range from 45 to 96. Your raw score, so for example, is an 83. Does this mean your score is in the 83rd percentile? That would be a no. Where is the 83? Right here at the 75th percentile. So if 75% of the students scored at 83 or below, what is your percentile? That's the 75. Okay, down that way. 75% of the data is at or below an 83. Okay. The way Alex explains this, the percentiles, it's kind of a little, they add one or subtract one here and there. Stick with the C definition that we had when you go with C's, that if 75% of the data is below, okay, that means how many data points? 75% of them are below, and 25% of them are above. So there's no subtracting one in that. If there are 40 students in the class, how many students got a score above an 83? So like I just said, 100 minus, that's the 100 minus the P thing, is 25% is above. So if you have 40 students and 25% is above, that's 10 of them that are got a score better than you. Okay, think about it. If there's only 40 students, then there are 10 in each quartile. So if 83 is here, there's 10 students here, right? 10 students here, 10 students here, 10 students there, because it has to be 25, 25, 25, 25% of the data. So each quartile, in this case, if there's 40 students, would be 10 students. Okay, so let's say your score was the 90th percentile. So you're up in here somewhere. What percent of the scores were at or below your score? Well, that's 90%. Above 100 minus 90 is 10%. So somewhere in, so here's your 90 score. 10% is here. Okay. What is the interquartile range of this data set? That interquartile range, 83 minus 69. Because that's what Q3 minus Q1 is 14 is your IQR. What is the spread of the smallest quarter? Right here is the smallest quarter. So Q3 minus Q2 in this case is 83 minus 78 is 5. That's your range of ages in between there. A test score of 72 would fall into which quarter? 72 would be here. So that's in the second quarter. Right? First, second, third, fourth quarter. The way that's get down to the end here. It's hard to keep that. I'll have to slide it back and forth here. All right. The first quarter has the largest spread. What does that tell you? Well, that tells me maybe this 45 is an outlier. Maybe it's way, there's 10 students in here for 40, if there was 40 students. And they're pretty spread out. So maybe this guy did extra worse than everybody else. I don't know. Um, it definitely tells me the scores, the actual test scores, or are more have a wider diversity or more spread out, not as opposed to this quarter where a lot of them are bunched together. There might be repeats. It's very typical to people to get between a C and a low B, right? Upper C and low B. So all 10 students, if there's 40, are bunched into this little one. 10 students are here. There might be a bunch over here, but there's definitely one minimum score way down here. Okay. So that begs the question, is 45 an extreme value? Support your answer mathematically. These are on the homework. So remember our formulas. This is your Q1 minus your IQR for the lower times 1.5. So our Q1 is a 69 minus our IQR 14 times 1.5. 69 minus 21 is 48. 48. So that means anything here, 48 and this way, are considered extremely low values. Therefore, they are outliers. All right, so 45, that's a yes for that, because that's the limit. Remember, the upper limits, just to double check, I mean, think about it. It's out of 100. There's nobody up here unless they got extra credit. But if they did, it's Q3 plus IQR times 1.5. This would be 83 minus 14 times 1.5, or excuse me, plus. So 83 plus whatever that is. Apparently, I did the math all together and it comes out to 104. So that's kind of like up here would be your extreme values here. And we don't have any of those. All right. So the last question is, if 70 is the passing score, did over half the class pass? Well, where's half the class? Half the class got below a 78. Half the class got above. So yes, over half passed. Almost 75% passed, because that's a 79. 75% of the data are up here. So almost 75% of the class passed. Okay.